Introduction to bat navigation. Bats are extraordinary creatures known for their ability to navigate and hunt in complete darkness. Unlike many animals that rely on sight or scent, bats use a unique set of skills to maneuver through the dark and locate prey. Their navigation system is highly sophisticated and relies on echolocation, a method that allows them to see using sound. Echolocation. The primary tool. Bats primarily use echolocation to navigate in the dark. Echolocation involves emitting high-frequency sound waves, which bounce off objects and return to the bat as echoes. By analyzing these echoes, bats can determine the distance, size, shape, and even texture of objects in their environment. This ability allows them to detect obstacles, find prey, and navigate through complex environments with remarkable precision. Emission of sound waves. Bats produce echolocation calls using specialized structures in their larynx. These calls are emitted through their mouths or nostrils and vary in frequency depending on the species and the environment. High-frequency calls provide detailed information about small objects and insects, while lower frequencies are better suited for detecting larger objects. The frequency and timing of these calls are adjusted based on the bat's immediate needs and surroundings. Reception and interpretation of echoes. The sound waves emitted by bats travel through the air and bounce off objects before returning as echoes. Bats have highly sensitive ears that can detect these faint echoes. The information gathered from the returning echoes is processed in the bat's brain, where it is used to create a mental map of the surroundings. This allows bats to visualize their environment in real time, despite the lack of visual input. Adaptations for echolocation. Bats have several adaptations that enhance their echolocation abilities. Their ears are often large and specialized to capture a wide range of frequencies. Some species have complex ear shapes that help direct sound waves more effectively. Additionally, bats can adjust the frequency and intensity of their echolocation calls based on environmental conditions and the type of prey they are targeting. Navigating in complex environments. Bats are capable of navigating through dense foliage, caves, and other cluttered environments thanks to their echolocation skills. By continuously emitting sound waves and interpreting the returning echoes, bats can detect and avoid obstacles, adjust their flight path, and locate prey. This ability is especially important in environments where visual cues are minimal or non-existent. Echolocation in different bat species. Different bat species use echolocation in various ways, depending on their ecological niche. Insectivorous bats, for instance, produce rapid, high-frequency calls to detect and capture insects. Fruit bats, on the other hand, rely more on visual and olfactory cues but still use echolocation to some extent. Some bats also use echolocation in combination with other sensory modalities to enhance their navigation and hunting capabilities. Social interactions and communication. Echolocation is not only used for navigation but also plays a role in social interactions among bats. Some species use echolocation calls to communicate with each other, either to coordinate hunting efforts or to maintain contact within roosts. The ability to distinguish between different types of echolocation calls helps bats identify individual members of their species and interpret their intentions. Limitations and challenges. While echolocation is highly effective, it does have limitations. For example, echolocation calls can be disrupted by environmental factors such as rain, wind, or background noise. Additionally, echolocation may not be as effective in detecting very small or very fast-moving objects. Bats have evolved various strategies to cope with these challenges, such as adjusting their call frequencies or using multiple sensory inputs. Conclusion. Bats' ability to navigate in the dark is a remarkable demonstration of the power of echolocation. By emitting and interpreting sound waves, bats can see their environment and locate prey with incredible accuracy. This sophisticated navigation system allows them to thrive in nocturnal and complex environments where other sensory modalities might be less effective. Understanding bat navigation not only highlights their adaptability but also provides insights into the broader principles of sensory perception and spatial awareness.